Have you ever just been completely captivated watching a figure skater? The way they whip into a spin, accelerating into this incredible blur, it almost looks like they're breaking the laws of physics. Well, today, we're going to break down the science behind that amazing athletic feat.
So let's just get right to it. How in the world do they do that? I mean, we are talking about speeds over 300 revolutions per minute. To put that in perspective, that's faster than some helicopter blades. It just seems impossible, like it has to be some kind of illusion, but it's not.
It all comes down to a simple idea. It's not magic, it's physics. Pure and simple, and we're going to unpack all of it. I promise, by the end of this, you will never look at a figure skating spin the same way again.
All right, so first up, let's tackle this gravity-defying illusion. We're going to see how these athletes are basically manipulating the fundamental forces of the universe to create something that looks, well, totally out of this world.
But here's the cool part. To really get what's happening on the ice, you don't need a fancy physics lab. Nope. We can start somewhere much, much simpler. In fact, just picture yourself in an office, sitting in one of those spinning chairs.
And that brings us to what we're going to call the office chair experiment. Because this is a principle so fundamental, you can actually feel it for yourself. Okay, so you're in the chair. You give yourself a little push, and you start spinning with your arms stretched way out. You're moving at a pretty slow, steady speed, right? Now, pull your arms in tight to your chest. What happens? Whoosh! You instantly speed up. It's not subtle. It's a huge change, and you can literally feel the forces at work.
And believe it or not, with that one simple move, pulling your arms in, you just demonstrated one of the most basic, fundamental laws of the entire universe. For a second there, you were a physicist, and you didn't even have to do any math.
So, what is this universal law? It's called the conservation of angular momentum. And now that you've felt it, the definition is actually pretty straightforward. It just means that the total amount of spin an object has, well, it has to stay the same. So, when you make yourself smaller by pulling your mass in toward the center, your speed has to increase to keep that total spin the same. It's a perfect trade-off.
So we've got the secret. Now let's take this principle out of the office and get it back on the ice rink.
And check this out, it is literally the exact same move. In your office chair, you pull your arms in, you speed up. A figure skater does the same thing, just with way more power and grace. They pull in their arms and a leg to get as much of their mass as close to the center as possible. And to slow down, you guessed it, you both do the same thing. Just extend your arms and legs back out.
And this is where the sheer athleticism is just mind-blowing. A skater is a true master of this. They don't just pull their arms in, they pull them in so tight it's like they're giving themselves a hug. They tuck that leg in and up, getting it perfectly aligned. Every single movement is laser-focused on one goal: centralize all their mass along that invisible line they're spinning on, the axis of rotation.
Which brings us to our last section, where it all comes together. Now we can really appreciate the physics of a perfect spin.
And here we are, right back at that incredible number we started with, over 300 RPM. But it's not a mystery anymore, is it? It's the direct result of an athlete taking that physical law we just talked about and executing it with absolute perfection, turning a science lesson into something breathtaking. So the next time you see a skater go into that dizzying spin, you're not just going to see a beautiful performance, you're going to see a scientist in motion. You'll see an athlete who has such incredible control over their body that they can manipulate a core principle of the universe to create something, well, something extraordinary. It's truly where art and physics become the same thing. And that leaves us with one last question to think about. We've decoded the spin, but this principle is absolutely everywhere. So now that you know what you're looking for, where else do you see it? Think about a diver tucking into a somersault, or a gymnast flipping through the air. What other sports are really just beautiful examples of science in motion?